cancer sucks, but thankfully over the years, especially recently, we have gotten better and better at being able to treat cancer. Enter into the chat nuclear medicine, specifically radiopharmaceuticals. Imagine a cancer-seeking missile that is meant to seek and destroy cancer cells that are difficult to find inside of your body. That is therapeutic radiopharmaceuticals. The use of radiation to treat cancer is almost as old as since we discovered radiation back in the late 1800s. You've probably heard of some of the treatments that we've been using for years to treat cancer, such as taking a radiation source and actually putting it right next to the tumor. And one of those examples is a brachytherapy seat. Another example is external beam radiotherapy, which is using an external beam, usually in an array, to fight things like brain cancer. And these types of radiotherapy still have great applications for today. But radiopharmaceutical therapy takes things to the next level. Here you can see a diagram kind of illustrating the difference between the two. In traditional radiotherapy, the one on the bottom here, you can see the radiation goes in a beam through this tissue. The yellow stuff is normal tissue and the red stuff is the cancer cells, and the radiation has to go through the normal tissue to get to the cancer cells. That means a lot more damage happens to that normal tissue. Radiotherapy, on the other hand, you can actually make it chemically seek out those cancer cells, none of it getting deposited in the normal cells and only in the cancer cells. And you can see the radiation is affecting the cancer cells for the most part. So how is it that we're able to target only the cancer cells with this radiopharmaceutical? Well, this chart right here really demonstrates exactly how we're able to do that. This is the radiopharmaceutical, and here is your cancer cell. Cancer cells can have these target proteins on them that have a very specific shape. If you can take create a targeting molecule with just the right shape that goes into that target molecule that's on specifically cancer cells, you can now link, using a linker molecule, that target molecule to a radioactive material. So this radiopharmaceutical will seek out the cancer cell, and the radioactive material will completely obliterate it. Now, I hold this radioactive material very near and dear to my heart. I actually get to help make this stuff, specifically non-carrier added lutetium-177. And this is at Shine Technologies, my employer, and it's at their facility called Cassiopeia, and it's actually North America's largest lutetium-177 production facility. Now, ever since I've worked in nuclear power and radiation technology, I've always had a soft spot for nuclear medicine. It's kind of one of those things that I told myself, you know what, if I didn't go to the nuclear power route or the other nuclear technology route, I probably would have gone to nuclear medicine. And now that I work at Shine, I kind of get to bridge both worlds. I get to do the nuclear stuff, and then I also get to make half-lives that save lives.